Hello everyone. In this video, we'll be modeling a battery. So we'll look into its state of charge. We'll have a look at the voltage. We'll have a quick look at the current cycle. So basically what in this video we'll be using is a sinusoidal current cycle. That is, it will start with a magnitude of 0 and it will go to minus 50 amperes and it will follow a sine curve and we'll be plotting the results for half a sine. That is, the frequency will be half. So let us have a quick look at our model. I have already prepared the model. The simulation time is 3142 seconds. Now there is a significance behind it, why it is 3142 seconds. If we have a look at the sine wave, so this represents the current. So let me just rename the block to current in amperes. So on the screen you will be seeing the formula for state of charge, that is the state of charge equal to initial state of charge minus integral of I divided by Q into 3600. Now why 3600 you would ask? So basically it is just a conversion of the battery capacity, that is Q, from amp hours to amp seconds. So this is what it represents. The BC is the full form for battery capacity. It is multiplied by a gain and the gain value is 3600. We'll take the current, we'll take the battery capacity, and we'll perform a division operation, that is current divided by the battery capacity. Since we are using an integral, I have imported an integral block. Now, now the initial conditions of integral block is set to ISOC, that is initial state of charge. Don't worry, we'll mention these variables in the MATLAB workspace. The initial condition basically gives a starting point that at t equal to 0, what value do you need as an output. Now that we are having current in negative, so it will subtract from the initial state of charge. Now remember, the initial state of charge is 100% and we are extracting current from the battery. So as the time passes, the state of charge will go on decreasing, that is from 100 it will go to 80, it will go to 70 or 60 and so on. Now this value, if we multiply it by 100, we get the value in terms of percentage. So let me just rename this as in terms of percentage. Alright, what we are looking here is a 1D lookup table. Now this lookup table accepts value as a state of charge as an input and it gives out the battery voltage. So corresponding to the state of charge, we'll have a particular battery voltage. I have included three scope blocks. The first scope is to visualize the current, the second is to visualize the battery voltage, and the third is to visualize the state of charge. So this is a mux block. A mux block basically combines all the values into a single signal output, and we'll visualize it using a two workspace block, and the variable name is SimOut. Let us run our simulation. Okay, so the simulation is complete. Before looking at the output, there is just one thing that I want to tell you, that the frequency is set to 0.001 radian per second. Now, why that you would ask? So basically, our simulation time is 3142, and if you multiply the frequency with time, so it gives us the value as pi. So the pi, what of a full wave frequency corresponds to 2 pi radian, as you all know. Now that we are simulating it for a half a sine wave, we need this frequency as half pi, that is half 2 pi, that is pi. Hence, the frequency is 0.001 radian per second. Alright, let us have a look at our current cycle. So in the full screen, you can see the current starts from 0 and at 1/4 of the frequency it reaches around minus 150 amperes, and at half the frequency it goes back to 0. So this simulates that, let's say for example, in the time of 0 to 500 you are using your cell phone as just like you are using it for text, or you are running a small application which doesn't require much current. However, At around 1500 seconds, say you are playing a mobile game, let's say you are playing a real racing or you are playing PUBG. So the phone will extract more current, that is in the negative. So extracting is negative, and when you charge it, it becomes positive. As time progresses, let's say you quit the application and you just closed your phone, so it will use less current. So I hope this is understood by you. Let us have a look at the battery voltage. So this is how the battery voltage. Now usually battery voltages are divided into three phases. The first is the maximum voltage, the second is a nominal voltage, and the third is a cutoff voltage. So the maximum voltage is represented in this area, the nominal voltage corresponds to this area, and the cutoff voltage corresponds to this area. So from the graph you can see that the cutoff voltage is close to 360 volts and the maximum voltage is close to 450 volts and the nominal is close to 400 volts. Alright, let us have a look at the state of charge. So this is expected result. The state of charge is 100%. That is when you are not using your phone, that you just started your phone from a battery of 100% and you started playing games, you use text, you use different types of applications, and the state of charge slowly began to decrease. And finally, the state of charge is around 10. So since the battery has a cutoff voltage, it won't drain it completely. So there will be some percent of battery present at the end of the day. So how to import all these variables that we just saw? Let me just show you an Excel sheet. So this is extracted from a battery specification.csv file. Here you can see the battery capacity, that is 93.6. This is watt. This is ampere hours. This is the nominal voltage that we just saw in the results, that is around 400 volts. This is the initial state of charge. Now this one represents 100%. That is, so it is basically divided by 100. So this one represents that the battery is 100% charged. This is the battery state of charge and battery voltage relation. So this is an experimental data, and the values are basically extracted from it. Yeah, so, okay, so that was a quick look at how do you model a battery inside Simulink workspace. I hope you guys enjoyed the video, and if you did, make sure you drop a like and also subscribe to my channel. Thank you so much.